Good day, folks. In this video, we are going to use cosine to solve for a missing side. Before I write down the cosine ratio, I think it's important for us to correctly identify and label our sides so that we know we're applying the correct trig ratio to the problem. And to start that process, we're going to begin by looking at the right angle. And right now, if we look at the right angle, we can see that across from that 90 degree or that right angle is the hypotenuse. And that's given to be 13 millimeters. But we're also given a reference angle of 59 degrees. Now, right next to that reference angle, or a side that's touching that reference angle, is x. And that's the side we're trying to find. And because it's right next to the reference angle, we label that as the adjacent side. So, because we're involving the adjacent side and the hypotenuse in this right angle triangle, the use of cosine is correct. So the cosine ratio is cosine of an angle that we're trying to find, or is given, is equal to the adjacent side divided by the hypotenuse. Now, our next step is to transfer the information from the diagram into the ratio itself. So we're looking at cosine of the angle, which is 59 degrees, is equal to the adjacent side, which is x, that we're trying to find, divided by the hypotenuse, which is 13. So, before we go any further, I think we'll take a decimal approximation for cosine of 59 degrees. We can use a graphing calculator or any calculator to determine that value for cosine 59. And when we do so, we should get a value of 0.5150. And that's going to equal to x over 13. So for us to solve, we're going to use equivalent fractions. We're going to put a 1 in the denominator because now we can cross multiply and solve for x, or to isolate x. So if we cross multiply, we have 1 times x, which is x, is equal to 0.5150 times 13. Or, when we are done, x is going to be approximately equal to 6.7, and our unit measure is millimeters. So that 6.7, that's smaller than 13. And since the hypotenuse should be the largest side, and we determine a value that's smaller than 13, it appears as though our answer makes sense, and as a result, our answer of 6.7 millimeters is correct.